Hello. In this video, I will do a dosage calculation uh, video. But we are dealing with pediatrics calculating maintenance fluids. So this is a pretty simple, straightforward video. You have done maintenance fluids before. So in this video, I will go over the calculation of maintenance fluids for a patient. Just remember, children and infants are more susceptible to diarrhea and dehydration, which can lead to serious complications such as hypovolemic shock. So, yeah, so let's go over this video real quick. So, in order to calculate the child's fluid requirements, we can use something called the Holiday-Seeger method. So this is how you would calculate maintenance fluids. Or the Holiday Seeger method. So, provide 100 milliliters per kilogram per day for the first 10 kilograms. So, whatever the patient's weight, um, yeah, add 100 milliliters per kilogram per day for the first 10 kilograms. Then you would provide 50 milliliters slash kilograms per day for the second kilograms, and then provide 20 milliliters per kilogram per day for any additional kilograms. And then add up all the three amounts. So it seems pretty straightforward. But if we're dealing with pediatrics, like I said before, pediatrics are more susceptible to diarrhea and dehydration. So if a patient is severely dehydrated, you simply do 1.5 or 2 times the maintenance fluid. So I'll explain. Okay, so let's do example one. Example one says calculate the maintenance fluids for a child who weighs 88 pounds. Round the answer to the nearest hundreds. Okay, so the first thing I would probably do is, let's do part A. So what does part A say? Part A says, how many milliliters of maintenance fluids does the child need in 24 hours? So how many milliliters of maintenance fluids does a child need in 24 hours? Okay. So yeah, first I would find the weight in kilograms, right? Because we have to convert everything to kilograms, right? Uh yes, everything in kilograms. So let's what I'm gonna do. So we said that the child weighs 88 pounds, so we're gonna convert that to kilograms. So 88 lbs times, and then uh this is something you just need to know. We know that 1 kilogram is equal to 2.2 pounds. I'm pretty much doing what's the met that method we dimensional analysis. And this has an invisible one. So if you recall or review, when you multiply fractions, you multiply across. So as you can see, the units of pounds disappears, and then you're left with kilograms on the top. And then you don't have to put you're still, yeah, this one's still here, but you don't have to put that invisible one. And then you just multiply across, not crisscross, but across. So what is 88 times 1? 88. And then what's on the bottom? What's 1 times 2.2? 2.2. And then what's 88 divided by 2.2? 40 kilograms. Oh, wait, that's not our answer. Why did I box it? So what we got to do is we have 40 kilograms, right? So what you got to do is first do the 10. So we're doing the Seeger rule. First 10 kilogram, second, and then the remaining is and 20. There would be the remaining would be 20. So let me show you. So yeah, let's do the first 10 kilograms. So we have a total of 40 kilograms, right? We got that 44 kilograms from the child's weight, which was originally 88 pounds. So let's do the first kilograms or the first 10 kilograms, right? Seeger's rule. So it's going to be so according to the Seeger rule, it says the first 10 kilograms, you provide 10 milliliters per kilogram per day. So really that is going to be 100 milliliters per kilogram times blah blah 10 kilograms over one. Okay. So if you do that, so the kilograms disappears and you're left with milliliters, right? We want milliliters because it says how the question says in part A, how many milliliters of maintenance fluids does the child need in 24 hours? So when you put it all together, so multiply across, so let's see, what's 100 times 10? 1,000. And then you have this invisible one. So that's going to be 1,000 kilograms. I mean, 1,000, these kilograms appear at 1,000 milliliters. Okay. Now do the second. So it's going to be the second 10 kilograms. So we did 10, so we need another additional. So it's going to be, so according to the Seeger rule, right? If we go back to this chart right here, it says provide 50 milliliters per kilogram for the second kilogram. So we have a total of 40, so we could do an additional 10 more. So it's going to be 50 milliliters per kilogram times 10 kilograms over 1. And then the kilograms disappears, and then you just multiply across. So 50 times 100 is 500. And then 1 times 1 is 1. You don't have to put that one if you don't want to. So you are left with 500 milliliters. So we said that this child weighs 40 kilograms. So we only did 10, 20. So we only did 20 kilograms. So we have a leftover, a remaining weight of 20 kilograms. So remaining weight is 20 kilograms. So it's going to be 20 ml. So wait, what does the chart says? The chart says provide 20 milliliters per kilogram per day for any additional kilogram. So we said we had an additional 20. So it's going to be 20 milliliters per kilogram times 20 kilograms over 1. So that's going to be 400, right? The kilograms disappears and you're left with milliliters. Now, you just add up the total amount. So it's going to be, your total amount will be 1,000 plus 500 plus 400. That's going to be a total of 1,900 milliliters per day. Okay, so that was part A. Now let's do part B. So what does part B say? Part B says, what would you set up the pump at in milliliters per hour? So you just basically take the answer from part A, uh, 1900 milliliters, and then you divide it. We know that in one day there's 24 hours, so it'd be divided by 24 hours. And what happens is 1900 divided by 24 is 79.1666. So that is going to be 79.17 milliliters per hour. Okay, so that was question B. Let's do question C. If the provider adjusts the order to include two times the maintenance fluid, so it looks like the person's dehydrated, how many milliliters should it be administered every 24 hours? So what you have to do is take the answer from part A. So we had so on part A we had 1900 milliliters per day, and then just times it by two, and you get 3,800 milliliters per day. D says, what is the new IV pump setting in milliliters per hour? So we want it in milliliters per hour. So take the answer from C and then divide it by 24 because they want milliliters per hour. So it's going to be, oops, hold on. Is that full screen? So it would be 3,800. So the answer from part C is 3,800 milliliters per day over 24 hours. And you get 158.333. The question says the direction is round to the nearest hundreds. So yeah, it says round to the nearest hundreds. So this would be 158.33 milliliters per hour. Okay, so that's it for this lecture. So I believe the next video will be pediatrics calculating intake and output. Okay, I am going to stop here.